and it's a blind chicken pecking away at the dirt. Right. There's more reasons why Wikto sucks. Okay. If we have something like slash, let's say big site, we can automatically start looking for files within those directories that we get, right? With Wikto, you can't do that. Wikto doesn't know about those things. If we have a directory that we find somewhere within our structure that is called, let's say, ABC intranet, then why don't we look for ABC intranet on other directories as well? Because it might just exist there as well. It doesn't do any of that stuff. It doesn't have that intelligence. It's not sitting in that loop, okay? And while we're looking at these directories and files, we can look for indexability of those directories as well. So that was the recon part of Suru, and you'll see if you look at the tool that there's a whole lot of different smart scanning and smart finding out where directories are, where files are, and it makes a lot more sense doing it inline with a proxy. And the other thing that you can do with Suru is also fuzzing. So as soon as we have a content comparison algorithm, we can say, let's send this stuff to our application, right, and see what comes back. And then let's say send something else and see what comes back, and we compare these two results. So let's say you have a form says username equals this, password equals that. We can basically go and we can say, in the part that says username, let's send a couple of fuzzing strings like SQL injection string, cross-site scripting, directory traversal, any of those things. We basically look at how the application behaves, and when it comes back, we match that response to a base response. And at the end of the day, what we can do is we can say all of these responses that we've now had, we can group them together to say those 900 responses, they all look the same. Those 90 responses over there, they all look the same. And these 9 responses yielded this kind of reply. Okay? Which makes it really easy for us to see how the application behaves under different circumstances. So in other words, if I send 1,000 different requests to the application, 1,000 different strings in there, modifying a single parameter, I can maybe get back just 2 different responses. Now doing it manually is just, it's a pain in the butt. So here you can see 2 screens. What we can do with our parameters once we get it in, we can nicely break it down into, get parameters, post parameters, cookies, the rest of the headers, all of those things. And we can give the user the ability to drop down on a drop-down list on any of these and say, this particular parameter, I want to fuzz and I want to see what's going to happen with it. So you see on the left-hand screen, you see action is left. On the right-hand side, I have the ability to fuzz those with different things, and we'll get into that. Okay, so let's do a quick demo of that. I'm just going to do one quick demo of that. Let's say we have a site like this. Okay, I'm going to clear this cache over there. Yeah, now is the time to give us network connectivity. Log into intranet, log in with, let's say, moo and moo. Okay, login failed. We get that request coming through there. We can see it's a post. It returned with a 200. We can double click on that, get that window over there. We've got username moo, password moo. I can select, let's say, all of the fuzz strings that I want to run. And click on browse. And on this side over here, you see that stuff starting to be tested. Nicely multi-threaded. Those files that we have over here, we can edit, of course, at any stage. Those are just text files. You can put in any of the text files, any kind of text files you want to have in there. Basic password list, common tables, any of those kind of things. Let's just see. Oh, I loaded union select there. Okay, let's just check. It's just a big file that it's loading up. Okay. So on this side, you'll see these are all the responses that we got back. And I can say group these together, auto group it. And we can see that it basically yielded 3 responses. First response says login failed. Most of the stuff came back with the login failed. The second response came back with a nice juicy MySQL error. And the other one yielded us to be logged in. So there's 3 different responses that we could get. those strings are just a whole lot of different fuzz strings that we put in there. That obviously comes with the proxy. So, getting back to this. I don't want to spend too much time. I don't want to steal time from Arun. You can fuzz anything in the HTTP header. You can anything in the HTTP request, any place, anywhere. You can see here we've actually fuzzing the user agent there because we just insert that fuzz point in there, and we can group results automatically. There's a couple of other things. I don't want to go into that. Can I go into that? You got the time? Okay. We have a thing called automatic relationship discovery that basically compares the MD5, the SHA-1's base64 encoded and base64 decoded part of any parameter with the parameter himself across all of the different parameters that you've ever had. So why do we do this? Well, for instance, if when you log into your application, you get a cookie, and that cookie is sent to you, and that cookie contains, let's say, the MD5 of your username, that's something you want to know. Because then things are like really not good at the application side, right? Or if you have a password that ever gets passed along by 64 encoded, the application will tell you this. You can also do search and replace on both incoming and outgoing streams with the ability to change binary data. As you can see here at the back, we changed the binary character 03 to 30, and it obviously affects your pictures quite badly because those are binary streams. So you can see the picture, Google South Africa there, coming out really bad. I'm not going to go through all of the reasons why Suru is nice, but in conclusion of this part, Suru is a nice new man-in-the-middle proxy. It really works well. It allows the analyst still the freedom of thought, doesn't try to do things for the analyst, but it gives the analyst kind of power tools to be able to create some of the things that they want to repeat over and over again. It is basically a combination of a useful proxy plus the best features of Webto, Crowbar, and EOR. And one word of advice, if you do work with Suru, it is better to start off with a bit of a more kind of non-complex proxy because it is an intense kind of tool. But if you do this every day, we use it every day, then Suru might be just the thing for you. We do hundreds of web application assessments, and we kind of know the stuff that bites us, so we basically wrote the thing to make our life easier. The URL you can find there at the bottom. And at this stage, I want to hand over to my esteemed colleague, Harun, that's going to talk about LR, which is the proxy of last resort. Not quite the same. That's a generic TCP proxy. This is more of a web application proxy.
Okay, in the absence of any esteemed colleague, I'm going to have to speak instead. And if I can get the projector going, that would be nice. Lit. Dun, dun, dun. Okay, really quickly. Horrible luck with mic. Okay, quickly for something completely different. Like Roelof said, Roelof's been speaking about the web proxy. What we want to go into now is just a generic TCP proxy. It'll allow you some of the same functionality, but its purpose is pretty much completely different. Okay, quickly the differences. Suru is a well-packaged tool. You see it's got the macOS-style buttons, addresses some unique needs. Okay, LR, we didn't even give it a name. It's pretty much a collection of other people's clever tools and some duct tape. Okay, a disclaimer, almost everything that you can do with LR, you can do in pieces with several other tools. Okay, LR just tries to make it simpler for you. Switches off. Okay, so LR just tries to make it all easier for you, and the point is gives you the chance to play with some of it. Okay, what does all this mean? For one, it means clearly I have no future in sales or marketing. Okay, so quickly what LR actually is. Okay, Someday, it'll be a completely suitable application for generic TCP connections. Today, it's just a bunch of scripts that let you get into a TCP stream to mess with stuff before you pass it on. Okay? There's pretty much the work done by us is almost nothing. There's 2 open source projects that deserve all the credit for it. One is Scapy from secdev.org, okay, and the other one is Neil's IPQ module. Okay, so we'll go into both of it. LR is a bunch of scripts written in Python, pretty much just because all the cool kids these days are playing with Python and we didn't want to feel left out. Okay, I'm not doing anything, I promise. Okay, pretty much why we do it is to get you freed from current tools. Okay, so there's a whole bunch of tools that you can use at the moment that force you to work a certain way. And we wanted you to have the ability to say, no, let's try it this way, let's mangle this. We want to shoot ourselves in the foot whenever we can. Okay, so the whole point of it is, in a way, just to get you thinking, to show you the possibilities for some of the fiddling that you can do with the stuff. And in some cases, just to show you how easy it'll be to do this kind of mangling. Okay, I had to pontificate some possibilities, but apparently my English was bad. Okay, so quickly, one of the questions you get straight off is people saying, you can use ngrep, you can use ITR, why are you doing this? And there's 2 reasons, well there's 3 reasons if I'm honest with myself. One was I just wanted to play with the stuff. The second reason was all those tools sometimes bump you into certain limitations. Okay, and the last one is all of those tools you've got to replace as your target server. So you, instead of aiming at your server, you aim at ITR and then let ITR relay your stuff through. And one of the things that we were looking for was the ability to mangle packets when you were doing malware analysis. Okay, so you had a box that was compromised with something, it's going out, you want to be able to say, okay, fetch this file. Okay, you're going out, don't fetch this file, fetch something else. So your malware thinks it's doing one thing and you have control over what you let your malware get. Okay, so ultimately our goal was to modify packets, payloads, and headers. We wanted to be able to do this within complex TCP streams, but as simply as possible for us. We wanted to do it in a nice scripting environment, okay, so it had to be Perl or Python because none of us started with Ruby yet. And we wanted to do it quickly so that we could retain our status as Minesweeper champion at SensePost. Okay, so currently you throw on a gateway, either IPQ or IP divert, and all we're doing there is hoping that the packets, or planning to catch the packets as they move through the kernel and move them to a user space process. Okay, once they get to user space, we have Scapy pick up the packet so that we can mangle it, and then we push it out through the kernel again. Okay, that is a complimentary Visio diagram drawn for no good reason. Okay, really quickly, I'm gonna give homage to Scapy. This year, Scapy ended up number 28 on Fyodor's top 100 tools, which means that most people haven't yet figured out how cool it is. Okay, there's a whole bunch of coolness hidden in Scapy yet. There's a bunch of guys putting out tools written with Scapy. If you haven't played with it yet, you really should. These 2 quick examples are stolen from the Scapy presentation, which was done by Philippe. And basically what he was going for is, he said, building packets shouldn't be any of this malloc, this, free, that stuff. You should be able to do it like you're ordering a burger.